Mr. Ryan, right?
Maybe.
Okay, so just imagine I have 3 bags, 3 different bags, okay? So 3 different kinds of bags. So each bag is given a number, 0, -1, 1, yeah? 3 kinds of bags. So the question is that we want to pick exactly K bags. There are only 3 kinds of bags, right? And then I tell you how many of each kind is. Right, so for example, like this is zeros, yeah? There are zeros, there are Z zeros. This is -1, -1, -1, and this is 1, so we say 1, okay? If we have 5 bags of 0, 3 bags of -1, and 2 bags of 1, and we want to pick a K bags, K is smaller or equal than these 3 numbers added together, okay? Obviously, right? So if we want to pick K equals 2 bags, so we want to maximize the sum. So what's the sum? Easy question.
You say everything's easy.
Okay, so to put it this way, not bags, right? 5 numbers, zeros. 3 numbers, 3 times -1. For number 1, we have 2 times. And we want to pick 2 times. We want to pick 2 numbers. We want to maximize the numbers we pick.
Is it 2?
Yes, 2. Okay. If I want to pick exactly 3 numbers, what's the sum? Look, I have 5 zeros.
But which one is the noun and which one is the amount? Which number is the amount and which?
Good question. This is amount.
Oh.
This is the number.
Oh.
Okay?
How?
So I want to pick 3 numbers.
The ones, 2 of the ones, and 1 of the zeros.
Yeah, so that's still 2, right? Okay, you get it. Okay, I want to pick 7 numbers. What's the sum?
You get all the 2s and then all the zeros.
What's the sum?
2.
I want to pick 8 numbers. What's the sum?
1.
Okay, you get that. Okay, so that's good. Do you understand now, Eric?
I don't really get it.
You don't really get it. Okay, Ryan, can you explain in simple words? Maybe I explain a little bit too
I
hard.
don't know how to explain.
It's hard to explain, right? So, do you understand this 0 -1, 1? I have 5 times of 0, 3 times of -1, 2 times of 1. The question is, I want to pick K, exactly K numbers. And K is smaller and equal than all the 3 numbers added up together. So, in this case, it's 10. K is smaller than 10, obviously, because there are only 10 items. I want to pick K item, which is smaller than 10, right? So, if we want to pick 2 items, obviously we'll pick the ones because they give a maximum. Then if I want to pick 3 numbers, so you pick from the zeros, right? It doesn't change. And if I want to pick 7 numbers, obviously you take all the 2s and all the zeros, right? The sum is still 2. If I want to pick 8 numbers, unfortunately you have to take a -1. Am I right?
Mm-hmm.
Make sense now?
No.
Which part you don't understand?
The last part. You said unfortunately you have to take away 1.
Yeah, because the question is that we have to take exactly K numbers. Okay?
Yeah.
So I want to find out the sum. What's the strategy?
To get the ones, all of them,
Oh,
and then and then get the zero so you don't minus anything.
Uh-huh.
And then if you have to get more, you have to use a minus.
so confused, but oh yeah. I thought you had to make a sum of 2, and I was like,
No,
2
no.
ones is 2, and it's like
Okay.
5 zeros and 2 ones is 2, and then I was so confused when you said you -1.
Okay, so let me rephrase this, okay? There are only 3 types of items. 0, -1, 1, right? The numbers. And we know exactly how many of each. Right? And we want to pick exactly, we want to pick K numbers. Pick K numbers, and we want to maximize the sum. Okay? So the strategy, yes, we pick the ones first.
You pick the bigger numbers because
Yeah.
what if all of them are negative?
Okay. So how do we solve this problem? As we said, okay, we pick these number first. We pick the ones. And if we still have to pick more, we pick the zeros. If we still have to pick more, we pick a negative one, right? Okay?
But what if it is like the case like 11?
That's a corner case. I like that. I like the way you think, okay? Corner case. What's corner cases?
Is where
when you pick more than that, right? Okay, so this is the requirement. It's smaller, so you can't pick more than 10 numbers here. Do you get it? Okay, so there's one corner case. Think about it. What's another corner case? Look, this is the corner cases. You want to pick more. What happened? Okay, so the question already said you can't pick more than that, right? This is the constraint. On the other hand, if we pick nothing, what happened? Right? If k is 0, then return 0. Just given these three numbers, right? Like this is the z neg 1, and then this k. How do we get the sum? Maximize sum. How do we implement it? Yeah, I know the solution is that, okay, we want to pick this, pick that, but how would you do it?
pick the biggest numbers.
If k is smaller than 1, what should we return? If k, you pick one number, what should we return? Just 1, right? Look, if there are 2 million ones, and if we want to pick 100, what's the answer?
100.
K equals a million, what's the answer? This is 2 million.
A million.
Yeah. And how about if I want to pick 2 million and 1, what's the answer?
2 million.
That's right, yeah. Okay, so we can do this if else, right? If else, we can check if this k is smaller than 1. If k is smaller than this number, right? Let's make it O, okay? Just to be different than this number 1. If k is smaller than O, then we return k. Otherwise, we need to pick all the O's. And we still have k minus O numbers to pick, right? And then we have to compare this number to this z, right? And if it's more than that, then we have to pick the minus 1, right? Does it make sense? Not very elegant, right? You have too many if else. How about if I tell you this array here, right? Minus 1, minus 1, minus 1, minus 1, right? And 0, 0, 0, 0. And 1, 1, 1, 1. Okay, so there are a lot. You know how many of these, right? This is n times, this is z times, and this is O times.
Does it just have to be minus 1s, 0s, and 1s?
Yeah, these are possibly 3 numbers. Only the 3 numbers. And if we want to pick k, so which side we need to pick? We want to pick the k numbers.
You pick from the right.
Yes. So, okay, so this is the array, right? And we want to just pick a from here. We want to pick k items. So how do we write it? Minus k to the n. And we will just need to return sum of it. Return sum of it. Return. So how do we get this a? We know these 3 numbers, right? So a equals n times minus 1 plus z times 0 plus o times 1, right? Okay, so we construct this and we return this. And obviously if k is 0, we have to check, otherwise it will not work, right? Because if k equals 0, minus 0 equals 0, and you will return the sum of everything, which is currently not the answer. So we have to check. If k equals 0, then return 0, otherwise return this bit, right? The time complexity for this one, check this one, the time complexity for this one. We have to construct this bit, right? And we have to do this, right? So the time complexity is O, this n plus z plus o, and plus k. K obviously is smaller than this term, so we can drop it. So it's O this one, right?
Which is
Right.
what?
Because we are constructing this array and we want to pick the numbers from the right hand side. Do you get it? Yes?
Yeah.
Okay, another way is simpler, but it's harder to think about. Let me write it here and you explain to me, okay? Return min k and with number of ones. Okay, ones. K minus 1 minus 0. Okay? And that's it. This bit,
This one is better.
okay, obviously why?
You always say I'm the last
No,
one.
no,
You
no,
say
it's-
it's much cleaner.
It's much cleaner, yes, much cleaner.
Yay!
Yeah, concise, okay?
Yeah.
This is the maximum, right? This is the maximum you can get. The ones. If ones is more, obviously you return k. If k is more, you return ones.
Yes.
This is 2
What if
million.
there's no zeros?
That's a good question. Let's take a look at that later. I'm saying this is 1, just 1. This is the ones we can get, right? If this is 2 million, this is 100. Obviously return 100. If this is 3 million, this is 2 million. Obviously return 2 million. Am I right? Yeah, there are 2 million ones. Okay, so now we pick the ones. Now we need to pick the zeros. If k is smaller or equal than 1s plus zeros, it doesn't change, right? If it's more than that, then we have to pick the negative ones, right? Am I right? Yeah. This is the thing, to pick the negative one. And obviously, if it's smaller than 0, then we don't have to pick, okay? Yeah. And do you notice here, there's no even mentioning about the negative ones because we don't need to use that value. Does it make sense?
Tiny bit.
A tiny bit. Which bit you don't understand?
I don't really understand.
So this is the picking the ones, right?
I don't really understand the k minus 1s minus 0s.
That's a good question. K minus 1. But you understand this bit, right?
Yeah.
Do you understand this bit?
Yeah.
Yes.
You pick the ones and then you subtract. You need to subtract what? In what cases does the answer change? If we haven't reached the step to pick negative one, it doesn't change, right?
Yeah.
Because if there are enough zeros, it doesn't change, right? So k minus 1s, because we have to pick ones here. Bless you. Look.
Yeah.
K minus 1, we have to pick ones.
Yeah.
And then we want to pick the zeros, right? And if we pick the ones and pick the zeros, if this number is still bigger than 0, what does it mean?
So you need to pick negatives.
Yeah, you pick a negative. If it's smaller than 0, it doesn't change the answer, right? Because here, max 0 here. If this is negative, this bit is 0. Minus 0 is 0. Only if this number is like 2. What does it mean?
You subtract 2.
Yeah, because we need to pick 2 negative ones, right?
Yes. What if there's no negative numbers?
Oh, that's a good question. That's a good question. Remember the beginning, k smaller than equal than 1s plus zeros plus negative 1, right? Yeah? If this is 0, yeah?
Yeah.
If this is 0, k will be 1s and 0. So if this is 0, so what happened? K minus 1s minus zeros smaller than equal than 0. So what does it mean? This is smaller than 0, then this bit is 0. Because there's an additional requirement. But that's very good. Make sense?
Yeah.
Okay, that's very good. Okay, so what have you learned today?
Well, we learned about this. So we
We learned about we have k back, no 3 back, and we want to find k, the maximum number you could get, and exactly k numbers of the amount of the bag.
Yeah, what's the strategy?
Basically, we get the ones, and then if there's a k is more, we have to go to the zeros. But if it's still more, we have to go to the negatives. Use the negatives on them.
What's the time complexity for this one? Can you
But
guess?
what if there's like nothing in the bag?
What do you mean nothing in the back?
There's no ones, no negative, no zero.
0, 0, 0. Yeah?
Yeah.
Then k must be 0. Because that's the additional requirement. K is smaller than equal than 0. So k is a positive number, so k is a 0. Non-negative number, okay? What's the time complexity?
Daddy.
Oh, come on. Answer this number right, then we finish.
Daughter.
We have done this. Do you remember? What's the number I should put here? Okay, what should I put here?
K.
Come on. What's the time complexity? We're just doing this math. What's the time complexity?
A 1.
Remember what did I say? What number should I put there? Right? Number, not a letter. Yeah? But it's all 1, right? Because we're just doing pure math. Yes? Does it make sense?
No. I'm kidding.
If you say no, I'm going to repeat, okay? Okay. Thank you. Bye-bye.